So in this session, we will be starting with speed, distance, time. So like time and work we have completed already. So most of the concepts that we have learned in time and work is applicable here, except that you are moving here. Okay. So in time and work, we have seen efficiency into time is equal to work. Okay. So here, this efficiency is actually changed to speed, okay, and time remained the same, is equal to, instead of work, it is actually a distance covered. So if you assume a case like a pizza boy, okay, so what is his job or what is his work? It's actually to travel a distance, okay. Now when you say that efficiency of that boy, means I am talking about the speed of that boy, right? So these two are actually same, and time. So in fact, these two are one and the same if you think in this way. Now the way they will make questions is like this. You will move in a train like this, in this direction. Sometimes two trains will move in the same direction, or one train will come in the opposite direction like this. And the same will be asked in a reverse way, like putting it horizontally, putting it vertically, like you will get escalators. Okay, so two escalators. Basically, these two trains and escalators are same. One is moving in horizontal direction, the other is moving in a vertical direction. Except that difference, both are actually same, right? So otherwise, you'll get questions like clocks. So that is actually moving in a circle, right, in this direction. So clock is also the same. Minute hand and hour hand is moving. So based on that, you'll get questions. And we are going to discuss all these questions, and you'll get boards and streams. Okay, so there also this concept of relative speed is applied. We'll be discussing about that in detail. Then you'll get questions like you are moving in a circle, you are running in a circular track, you are running in a normal straight line. Okay, so these kinds of questions we'll be trying to solve. So we'll try to see all the possible questions, right? So I'm not telling you that I'll take up 1,000 questions or 100 questions and I'll make you to solve everything. Rather, I will take up maximum 20 questions. Okay, now then I tell you these 20 are the only possibilities that you can get from speed, distance, time. The thing is, the data may change, okay, the situations may change, the scenarios may change, the numbers may change, but the question remain the same. It's like you have a linear track like this, okay? So a person is starting from here, another person is starting from here. So when they are meeting for the first time, how much distance covered? Okay, if I can ask you when they meet for the first time, how much distance covered, it is actually 1D, right? 1D, one distance is covered. If it is 100 meters covered. So if I can ask you when they meet for the first time, how much distance is covered, I can also ask you when they meet for 100th time, how much distance covered, or when they meet for 10th time, how much distance covered, or when they meet for 5th time, how much distance covered, 50th time or 500th time. The logic remains the same. If you know the answer for the first meeting, how much distance covered, and you can apply it across, right? So what will happen when they meet for the second time? If you know that, then this question is solved. See, when you are moving in linear track like this, one person going like this, another person coming like this. When they meet for the first time, together they covered a distance, total distance. Okay, now when they meet for the second time, what is going to happen is, see, this person will come like this, he will reach here, and this person will also reach here. Okay, so now if you see the distance covered by both of them together is, this person covered a distance and this person has also covered the distance. So 2D is over already, but still they are not meeting. Okay, they are not meeting. So what will happen is, this person will come back and this person will also come back like this. So when they meet somewhere, you don't want to know the point. So I teach you the way you will find the meeting point also. But I'm just telling you, if you know the distance, everything else is fine. If you know the distance and if you know the speed ratio, you can find where and when and any questions, where they are meeting, when they are meeting, how much distance they covered, everything you can find out. So if you see here, when they meet for the second time, the distance covered is actually 3D. First time 1D, second time 3D. Now if you continue like this, next time, third meeting 5D, fourth meeting 7D, like that it will go. So if it is 10th meeting, you can understand now. Okay, so third meeting I told you 5D, fourth meeting 8D, fifth meeting, like that it will go, right? See, so now this is one of the examples that I am discussing. Okay, so first meeting, if you see, one distance is covered. Second meeting, I told you already 3D. Third meeting, it will be 5D. Fourth meeting, it will be 7D. Now you can see the pattern here, 2n minus 1, right? So just need to know the number of meeting. If it is 10th meeting, 2 into 10, 20 minus 1, that means 19D will be covered. And if you know the distance as 100, answer is 1900 meters. If it is 100 meeting, 200 minus 1, that is 199D will be covered. Now if you know the distance is 100, this much is the answer. Any question you can solve just by knowing this. Now what they can do in this case, the story will remain the same, moving like this. The other possibility is both will move in the same direction. Okay, so in this possibility now, this is the only way in which they can make it difficult. They will only change number of meeting. It can be 10, 20, 30 or whatever it is. Now, if you know once that this is 2n minus 1, there is no point in, thinking about it. The moment you see the question is 25D or 25th meeting, what is the distance covered? 25 into 2, 50, 50 minus 1, 49D. And if you know the distance is 100, 4900 is the answer. Okay, so now what is the other possibility? Other possibility is like there's a circular track, or again you have the linear track. We'll come to circular track later. I'm just discussing an example here. So since I've discussed about moving in opposite direction, let me quickly discuss about when they are moving in same direction also. So you'll move like this, person A. B also will move in the same direction. So let's suppose B is having more speed. When they start, they meet, but then they are not going to meet, right? Now there is a possibility of meeting only if this person having more speed reach at this point and when they come back. So they meet. Now when they meet, how much is the distance covered? This person covered this much, second person covered this much. So the total distance covered is actually 2D. So first meeting, 2D. Second meeting, 4D. Third meeting, 6D. Fourth meeting, 8D. Now, 10th meeting, 20D. And if the distance is given as 100 meters or 200 meters or whatever it is, hardly they can do this only, right? They can change this distance and they can ask you 25th meeting, 50th meeting, 100th meeting, or what? 100 meeting means 200D. And if you know the distance is 100 into 100, that's your answer. Okay, so this is what the approach that we are going to use. We are not going to, so once I have done this, there is no point in solving hundreds of questions now, right? So similar approach is what we are going to use in all those cases. But one point which I need to tell you is the product constancy rule that we have learned across topic. I have discussed that in ratio proportion. I have discussed that in fact in profit and loss. Again, I have discussed that in percentage. I have discussed it in time and work. Here also I will be discussing towards the end of the session, but that is the most important point that you need to remember. Okay, so why that is important is because this is speed into time is equal to distance chapter. If you consider this as a chapter, otherwise I will consider it as AB equal to C, then we have all the chapters completed together, right? Or efficiency into time is equal to work, okay? Or efficiency into time is equal to volume of the tank filled, rate into consumption is equal to expenditure, length into breadth is equal to area. All these chapters covered together with this rule. What is the rule? If speed is increasing, time will come down. If A is increasing, B will decrease if C is constant. So here, if speed is increasing, time taken will be less when distance is constant. So the idea is from your home to office, the distance is same. Okay, so if you increase your speed, the time taken will come down. If you reduce your speed, the time taken will increase. Why? Because the distance is same. Okay, so you can say speed and time are inversely proportional. So let me start off with this. Speed into time is equal to distance. From this, what you can understand is speed and time is inversely proportional. Speed and time is inversely proportional. In which situation? When distance is constant. So when distance is constant. Now, from this itself, you can understand the formula of time. Time is equal to D by S. So here, if time is constant, now let's keep time as constant. This is a basic, okay? If time is constant, then if distance increases, you will have to increase the speed. What is the situation? You are allowed to take only 1 hour. You cannot take more than that, okay? So if the distance is increasing, you will have to increase the speed, then only you will reach in 1 hour. So distance and speed are directly proportional. If distance increase, speed increase. If distance decrease, speed decrease. In which situation? When time is constant. So I can write it as distance is directly proportional with speed. In which situation? When time is constant. Similarly, you can write speed as distance by time. So here, if you keep the speed as same, you fixed your speed as 40 km per hour. 40 km per hour, okay? Now, if the distance increase, the time taken will increase. If the distance decrease, time taken will decrease, okay? So, distance also, again, you can see directly proportional with time when speed is constant. So, these are three relations that you need to remember, or these are three formulas, if you consider these as formulas, okay? So speed is inversely proportional with time when distance is constant. Distance is directly proportional with speed when time is constant. Distance is directly proportional with time when speed is constant. Okay, so with a simple example you can understand this. I give you one simple example so that it will be fixed in your mind. Okay, so let's take a case of a car. Okay, a car is moving at a speed of 20 km per hour. Okay, for the first 3 hours. Then at 60 km per hour, next 3 hours. Okay, now what you need to do is, I'll ask you a different question. First you need to find the distance ratio. Okay, distance ratio. Find the distance ratio. So here what is constant? If you see here, time is constant. Okay, so when time is constant, we know distance is directly proportional to speed, and we know the ratio of the speed 20 and 60, that means 1:3. So the distance ratio will also be 1:3. I hope this is clear. Okay, why? Because distance directly proportional with speed when time is constant, and you can see time is constant here, 3 hours and 3 hours. So distance ratio is what they asked. If you know the speed ratio, that will be the same, because distance is directly proportional to speed when time is constant. Okay, second situation, I'll give you a different situation. I tell you first half you cover 20 km per hour, second half 60 km per hour. First half 20 km per hour, second half 60 km per hour. So here what you need to do is find the time ratio. That's what you need to find. So here what is constant? If you see here, the distance is constant, first half and second half. So when distance is constant, we know this is speed into time. So time and speed are inversely proportional, right? Speed and time are inversely proportional. And what we know, the speed ratio we know 20 and 60, that means 1:3. This is the speed ratio. What is asked? Time ratio, that will be 3:1. So time ratio will be 3:1. I hope this point is clear for you. Okay, now let's look at a third scenario. First half 3 hours, second half 1 hour. So here I am, instead of for speed I am giving you time taken. The ratio of time taken is given, but the distance is constant. So when distance is constant, speed and time is inversely proportional. So time ratio is given as 3:1. So if I ask you speed ratio, it will be 1:3. This is inversely proportional, right? Now let me give you one more question in this fourth one. 3 hours 20 km per hour, 1 hour. First 3 hours 20 km per hour, next 1 hour 20 km per hour. So here there is nothing to say that the speed is constant. So distance and time, when speed is constant, see, speed is constant means speed is equal to distance by time, right? So what is this ratio? Distance and time is directly proportional. So time ratio is given as 3:1. So what will be the distance ratio? Distance ratio will be 3:1 itself. So if you look at this case, here the application of distance is directly proportional to time. Okay. In the first case also, distance is directly proportional to speed. In this case, time ratio is what they are asking. So what is the equation or relation? Time is inversely proportional to speed. Here also time is inversely proportional to speed. So I hope this relation is clear for all of you, because this is what we are going to use in the next coming sessions. Now if you look at some important units, okay, so time important units are second, minute and hour. I tell you the conversion, okay. So if you see the distance, okay, so three aspects are speed, distance and time. So let's see the units of each of this, okay. So time units can be in seconds, it can be in minutes, it can be in hours. So distance, it can be in meter, it can be in kilometer, it can be in miles, it can be in feet also. Okay, so these are 4 units that you generally expect. Then speed, it can be meter per second, it can be kilometer per hour. I tell you the way in which you'll convert this. Okay, so speed is actually distance by time. Okay, so speed, this is a unit, meter per second. Why meter per second is because distance in meter and time in second. So that's why meter per second. Meter, distance, time, second. Now, or you can take kilometer per hour, right? So distance in kilometer and time in hour. So that's why kilometer per hour. Now let's see some of the conversions that also you need to be very clear with when we solve questions in speed, distance, time. So if I ask you what is 1 kilometer, 1 kilometer is 1000 meter or 0.6214 miles. Now what is 1 mile? That is 1.609 kilometer. You can when you solve questions, you can just take it as 1.6 kilometer. Okay, now this is easy to remember. This is 0.6 miles. 1 kilometer is 0.6 miles. 1 mile is 1.6 kilometer. So this 0.6 will or may help you to remember this. 1 mile. Okay, this is 1 mile. 1 hour. Obviously, you know 60 minutes. So if you need to convert 1 hour into seconds, 60 minutes, and 1 minute is 60 seconds. So 60 into 60, that is 3600 seconds. Then if you see 1 kilometer per hour, that is 5 by 18 meter per second. Okay, now why you are getting 5 by 18 meter per second if you ask me? 1 kilometer, how many meters? 1000 meters. 1 hour means how many seconds? 3600 seconds. Okay, so when you get these things cancelled, and you will get 2 by 5 by 18. You can cancel 10 and 36 with 2. So that's how you'll get 5 by 18. So if you need to convert, okay, so what is 1 meter per second? Because sometimes in kilometer per hour is given, you need to convert to meter per second. Sometimes kilometer per hour is given, you need to convert into meter per second, like that, okay. So meter per second means opposite of this. So that will be 18 by 5 kilometer per hour, okay. Now how to remember this easily? To convert to kilometer per hour, you need to multiply with 18 by 5. So 5 by 18 and 18 by 5, you will have confusion. Which one is larger? 18 by 5 is larger. So which one is larger in terms of meter per second and kilometer per hour? Kilometer per hour is larger. So when you need to convert to kilometer per hour, multiply with 18.5. That is a larger value. That's how you can remember. Kilometer per hour is larger. So 18 by 5 or 5 by 18 is larger. 18 by 5 is larger. So when you need to convert to kilometer per hour, multiply with 18 by 5. When you convert to meter per second, multiply with 5 by 18. That is a smaller. Okay. Now 1 kilometer per hour, you can also write it in terms of miles per hour. That is 5 by 8 miles per hour. See, that is also easy to remember. Instead of 5 by 18, 5 by 8. Okay. Now 1 yard is equal to 3 feet. Sometimes you will get questions where 2 batsmen are running. Okay. See, they can make a very difficult question in this scenario, because see, when train, what is the logic of train question? See, two trains are coming in opposite direction, so they are making a question based on relative speed and the distance covered, etc. Right? Same can happen here when 2 batsmen are running. When they cross, by what time they cross, all these things depends on their speed and the starting time. Okay, so you can get difficult question, because here they may not use the standard unit like kilometer per hour, okay, or the speed may be in kilometer per hour, but the distance may not be in kilometer per hour, because they will give you the length of the pitch, or sometimes you need to assume the length of the pitch also. It's like it will be given in yards, 22 yards, something like that. Okay, so yard means it's 3 feet, and 1 feet means 12 inch, and 12 inch means, or 1 inch means 2.5 centimeter. So 1 feet means 30 centimeter. So basically you can see that 30 centimeter scale, that is actually 1 feet. So 1 yard means 90 centimeter. It's not 1 meter. So you cannot say, when I say 22 yard, it's not 22 meters. The length of the cricket pitch is not 22 meters. It is slightly less. Okay. So if I ask you to convert 60 kilometer per hour into meter per second, what you will do? You need to convert to meter per second. Meter per second is smaller, so you need to multiply with the smaller, 5 by 18. Okay, and you get the answer. So if I ask you to convert 90 meter per second into kilometer per hour, what you'll do? Kilometer per hour is larger, so you'll multiply with 18 by 5. Okay, now let me give you a tough calculation or conversion here. You may think it tough, because in some question, let me give you 90 meter per minute. Meter and minute. You need to convert this to kilometer per second, because options are in kilometer per second. Then what you will do? First you need to convert this 90 meter into kilometer. How will you do that? 90 by 1000. That's the numerator. Divided by this minute, you need to convert to second. You multiply by 60. So 1 into 60. And you can write it as 0.0015 kilometer per second. And that calculation you can do. That's not a problem. But this is the way you need to convert it. Okay. So I hope this is clear for all of you. Now let's look at a very important concept, that is average speed. Okay. Average speed. See, average speed means it's actually total distance by total time. So what is actually speed? Speed is equal to distance by time. So average means total divided by number, that we have already seen in the previous session. So here total distance divided by total time is the average speed. Okay. So if you're traveling a distance d1 at time t1 and d2 at time t2, and d3 distance at time t3. So all these are given. So what is the average speed if I ask you? d1 plus d2 plus d3 divided by t1 plus t2 plus t3. So this is what average. So if I ask you, see a person traveled 10 kilometer in the first hour, 20 kilometer in the next 2 hour. Okay, so in the next 2 hour. So what is the average speed? So average speed here is distance covered 10 plus 20, that is 30. Number of hours or time taken 1 plus 2, that is also 3. So the average speed is 10. Okay, so distance covered by time taken, that's what average speed. Now in some questions you'll see first 1 hour you will travel at 20 kph. Now instead of distance I am giving you speed. Okay, next 2 hour you are traveling at 40 km per hour. Then you are asked to find the average speed. But what is average speed? Average speed is actually distance by time. Total distance by total time. So here can you find the total distance? Yes, speed into time you'll get the distance. So first case you travel 20 km with in the first 1 hour with 20 km per hour speed, right? Then next 2 hour 40 km per hour speed. So you covered 80. 80 is the distance covered. Divided by time is 3. So 100 by 3, that means 33.33 is your average speed in this case. Okay. Now again look at a different situation. First one hour you travel at 30 kph. Next 1 hour you will travel at 40 kph. Okay. In this, if I ask you what is the average speed, you just need to take the simple average of the speed. Why? Because simple average means 30 plus 40 divided by 2. Okay. Why? Because see, this total distance by total time is what you need to do. How will you find the total distance? Speed into time. Here also speed into time. So 30 into 1 plus 40 into 1 divided by 2. So that's what you are finding here. Okay. So remember this case is what we call as time constant. Time constant and speed is given. So average speed is simple average. Now this time can be 2 hour also. But still you just need to take the simple average. 30 plus 40 by 2. You don't want to do, see, otherwise what you need to do? 30 into 2 plus 40 into 2 divided by 2 plus 2, that is 4. Because 30 into 2 is the distance, this is the distance, so total distance by total time. But what will happen is, you can take 2 out, so 30 plus 40 divided by 2 into 2, this is getting cancelled out. So effectively you are getting 30 plus 40 by 2 itself, here also the same. So the point is, when time taken is same, and 2 speeds are given, you just find the simple average of the speed. So when the time taken is same, you just find the simple average of the given speed to get the average speed. What if 3 speeds are there? First 1 hour 20 kph, next 1 hour 30 kph, next 1 hour 40 kph. Then also you need to do the same thing. Take the simple average because the time taken is same. So 20 plus 30 plus 40 divided by 3. 1 plus 2 plus 3. Okay, so you'll get the average speed. Now what if it was 2 hours? Still the time is constant, right? In 3 cases time is constant. So what is the average speed? 2 into 20, that's the distance. Here 2 into 30, 2 into 40. And number of hours total, if you see 2 plus 2 plus 2, that is 6. So I can write it as 2 into 3. So when you take 2 out, 20 plus 30 plus 40 by 2 into 3, and this 2 will get cancelled out and you are getting the same thing. So the point is, when the time taken is constant, you just take the simple average of the given speed. So if 3 speeds are there, add all and divide by 3. 3 speeds divided by 3. 2 speeds are there, 2 speeds you add, divide by 2. Simple average is what you need to do. But there is a different case when that is also a pattern, right? See, generally if the question is about average speed, total distance by total time, you can find it, but you don't want to think of this. If the time taken is constant in 2 cases and 2 speeds are given, take simple average. Instead of time is constant, you can get speed or the distance as constant. Okay, like this. From A to B you are moving. You are going from home to office at 40 kph, and when you come back at 60 kph. Here if you see, the distance is constant, that is fixed at A to B. So when distance is constant, the easy way to find the average speed is harmonic mean. Okay, I will discuss about harmonic mean in detail when we discuss about AP, GP and HP. Okay, so here the answer is, let's suppose 2 speeds are given like A and B. The answer is 2AB by A plus B. Like here 2 into 40 into 60 divided by 40 plus 60, that is 100. So effectively you will get 48. Why? This is 2400 into 2, 4800 divided by 100, 48. Okay. So two concepts that we have discussed is, when time taken is constant, if you need to find the average speed, if the speeds are given, you just need to find the simple average. If two speeds are given, like A and B, A plus B by 2. If three speeds are given, A, B, C, A plus B plus C by 3. That's what simple average. Now, if the distance is constant, then you need to find the harmonic mean. Okay, so it can be like this also. Rather than going and coming back, see, you have to travel a particular distance, A to B. They will tell you the first half you cover at 40 kilometer, second half you will cover at 60 kilometer. Then what is the answer? Okay, here also you need to find the harmonic mean, that is 2AB by A plus B. So you can write it as, and you'll get 48 as the answer, like we have solved it. Now the same question you can get in this way also. You have to travel A to B, 1/3 of the distance you traveled at 40, next 1/3 you traveled at 50, next 1/3 you traveled at 60. So this is 1/3, this is 1/3, this is 1/3. Here also the distance is same and you got three speeds. Here you need to take the harmonic mean, but don't think that the harmonic mean is 3ABC by A plus B plus C. In the previous case it was 2AB by A plus B. Here it is not like this. You need to do it normally, like, see, when 2 are there, it's like 2 divided by 1 by A plus 1 by B. That's the answer. Originally, see, if you have 3 speeds or 4 speeds or 5 speeds, it's like N divided by 1 by A1 plus 1 by A2 plus 1 by A3 plus etc 1 by AN. That's what harmonic mean. So when 2 are there, 2 divided by 1 by A plus 1 by B. Now if you take the LCM, it's AB. So that's why 2 divided by A plus B by AB, and this AB will go here. So 2AB by A plus B. When 3 are there, what you need to do is 3 divided by 1 by A plus 1 by B plus 1 by C is what you need to do. So here in this case, 3 divided by 1 by 40 plus 1 by 50 plus 1 by 60. This calculation you need to do if you need to get the average speed in this question. Okay. Now see, you will get questions like this. There is a marathon, or just take a situation. I am not telling you marathon or anything. So A to B distance you need to travel. So 1/3 you travel by walking. Okay. And 2 km per hour. 2 km per hour was your speed. Second 1/3 you are running. First 1/3 you are walking at 2 km per hour. Second 1/3 you are running at 6 km per hour. Third 1/3 you are cycling at 9 km per hour. Okay, 9 km per hour. Or you can put some realistic value if you want. You can put this as 3 km per hour and this as 6 km per hour also. Okay, then what is your answer? What is the average speed of the entire journey? So the question is, first 1/3 2 km per hour because you are walking, then you are running 3 km per hour, then you are cycling 6 km per hour. It can be anything. Okay, now the speed can also be anything. Instead of 220, instead of 3 it can be 30, instead of 6 it can be 60 or 90 or whatever it is. What is the way in which you will get the answer? How many speeds are there? 3. So numerator is 3 divided by 1 by A, 1 by B, 1 by C. So here 1 by 2 plus 1 by 3 plus 1 by 6. You can't just write 3ABC by A plus B plus C. You have to do this. Take the LCM. 6 into 3, 18. Okay. Then final answer will be 3 km per hour. That's your average speed. So I hope this concept is clear for all of you.